All right, let's start. Good afternoon, everyone. I've been receiving some questions regarding the assignment, me, the teacher assistants, they have had received. So we tried to answer them all. But since we're in the class, I'm just wondering, do you have any questions now? Some confusions which we can actually clarify now? No? So you think assignment was all right? It was easy? Yeah. Yeah, sure. Like the one on binary, I have not specified them. Okay. I think I tried to specify them, but it could be that I was not able to explain them properly. But could you and I take a session afterwards? I can go through them. But does anyone else have problems with the binary assignment? I mean, if you do, just have a talk. We can talk about it afterwards. So the thing about binary is that this is to show you how data labeling is done in real life. It's a very easy part of the assignment. So most of the times you have to just do click and click. So do it. If you don't do it, you will fail the assignment. But if you do it, it'll take you 5 minutes to do it. So it's a very brainless activity because you just have to do click, click, click. And the whole purpose of it is to show you that data labeling is a very brainless activity. But it has to be done for supervised learning. Cool. So Theo and Atka, do we have a lab schedule? So, okay. I didn't see anything in the Slack, so I'm not sure what the plan. Great, good idea. Yeah, good idea. Okay, because I think Sims. Yeah. It's maybe better to help them with the assignment. I agree. Yeah, because everyone has a deadline on Monday, I think, for the assignment, so it's better to help them out with the assignment. Okay. So today we're going to continue working on machine learning. Now, last time we had the first lecture on machine learning. This would be lecture number 2. And we're going to cover 2 more parts of machine learning. So 2 more weeks on machine learning, and then machine learning will be done. When we are done with machine learning, most of AI will be done. So then we'll talk about ethics in AI. We'll talk about the problems with AI. We'll talk about more of the conceptual work stuff with AI. But I would request you to pay attention in at least these 3 classes because machine learning is the core of AI. If you are, I mean, we'll try to cover natural language processing as well if you get the time. I'm hoping if I can actually get the time to do that. But the thing is, like, when the second part of machine learning is over, we'll give you an assignment on machine learning. Create like some sort of algorithm using one of the algos. And then there will be a third assignment, which I kind of forget what kind of assignment that would be. So in total, we have 3 assignments, 1 project, and then the final exam. How many of you have registered for the Python crash course? Oh, quite a lot. That's cool. I think they're going to be like, or how many of you tried to register and could not enroll? Oh, all right. Sorry to hear that. So I've communicated this with the dean and the faculty as well. So the problem is that we are trying to officially launch a Python development course, but that takes time because when we come up with the idea, we have to get it approved for at least 10 different faculties. So my boss, Gustavo, is actually working with that right now. But in the meanwhile, we try to offer like an unofficial Python course with the help of students. So these students who are offering the course, they are like, they are working in the nucleus lab. So they are kind of paid by the university to work over there and help other students out. They decided, with our advice, of course, that it would be better if we could have like a workshop on this Python course. So that's why it's limited to 20 persons only. If you did not get chance in the first workshop, send them an email, try to sign up for the second workshop or the third one or the fourth one. And hopefully you will get the chance in that one. In the meanwhile, I would request you all who do not have any experience with Python to send an email to me that you don't have experience with Python and you're trying to get admitted to this crash course and you could not get a place. The reason I'm asking you to do that is because we need this documented list of how many students could not get admission to the Python crash course. So we can use that as a sample while making our case for the original Python course. And the way it should have been done is that you should learn Python before you come to the introduction to AI class. But it didn't really go that way this year or the last year. So could you send me an email? Just, if you are frustrated, we want to show that frustration forward. This is a class of almost 147 students. So even if I get an email from like 50 of them, that'll be great. So we can combine them. We'll make it anonymous. We'll take away the names. We'll just count like these are the emails we got. And then this will actually help our cause to create the Python course. All right. Let's talk about the machine learning algorithms. Last time we discussed that there are 4 kinds of machine learning algorithms. If we look at them on a high level. So they are supervised learning, unsupervised learning, reinforcement learning, and recommender systems. So today we'll go like further down and we look at supervised machine learning. Just to give a quick recap, supervised machine learning is a machine learning activity where you label, you kind of tell the model that this is this specific kind of data set. That is where data labeling comes in. So you use a labeled data set, you feed it to the algorithm, and the algorithm will then be able to make the right prediction. And supervised machine learning is used a lot. There are a lot of further algorithms down in supervised machine learning. And yeah, so since there are a lot of areas in supervised machine learning, they're further classified into 2 big areas. One of them is called classification. So you have a classification set of machine learning algorithms, and then you have a regression set of machine learning algorithms. So we're going to study both classification first, then regression, and then we will study a few of the algorithms. There are a lot of algorithms in this area. We'll study a few of them just to give you an idea on how the algorithms work. For example, linear regression algorithm will talk about different functions inside that algorithm. There are a few mathematical equations in it. We'll talk about those. So for one algorithm, we'll deep dive into that algorithm and try to see which factors influence that algorithm while working on it. And once we are done with that deep dive, we will then cover the remaining algorithms on a very high level. Because when you are doing an actual programming, you just need to know which algorithm to use in which use case. And most of the time, the use cases are the same. Like either it's recommendation for passenger count, for example, in case of router, or you're trying to predict the weather. So depending on the use case you're working with, you understand what the business rules are. And for when you are working on your own algorithm, you will know which model to use. So that's what we're going to try to teach you. Like if you have like a use case coming in, think about the use case and you'll be able to see like, hey, I think this is a classification algorithm. And within classification, I think we should use random forest to solve it, for example. Or you look at the use case and you're like, hey, I think this is a regression type of algorithm, and I should use linear regression to solve it. So we hope that you can get trained yourself in that. Oh, by the way, after 2 weeks, like the third week from now, that would be, I think 14th of October. So I'm inviting like a guest lecturer from Ruther. He is the head for the driverless cars project. So he's gonna talk about how driverless cars is one small thing we are working with. So he's responsible for all the mobility services inside Oslo and Akershus. So they're gonna talk about how they work with how they work with electric scooters, how they work with driverless cars, how they work with schoolicious bus. There are many services we have out, and how this mobility department is actually managing all of them. There are 2 departments in Ruther which work with artificial intelligence. One of them is mine, which works with data services only. And we look at data, we use AI to actually predict on how things will improve. The other department is focused on the hardware side of things. This is that department. So I think it's important for you to get an idea from them. But they will not only talk about driverless cars, they will talk about a lot of the things, including driverless cars. So I mean, think about the questions you could ask them. I'll share more details when I get a confirmation from him. The second guest lecture I'm trying to get from Nav. There's this lady called Catherine. She's the head of data science at Nav. I think it'll be important if you get a perspective from her on how data science and AI is implemented at Nav. Is there any other company you would like to talk to when it comes to AI within Norway? Huh? I could, but we invited someone from Google some while back inside another company. But the problem with Google is they try to sell themselves. I mean, if there's a huge requirement that you want someone from Google, we can set it up. Because everyone wants someone from Google. Send me a, yeah. Kongsberg. Yeah, I could, yeah. We can talk to them. Are they offently or are they private? I'll check. It's easier for me to go through offently, but I mean, private can also be done. Okay. All right. So I have 2 options now, Google and Kongsberg. If any one of you thinks of anything, just let me know and we'll try to make, this is the time we have, the next 2-3 weeks, and we can make it happen. Beyond that will be too late, because then you have exams, then you have to submit the final project, and it's Christmas, people get busy on those things as well. So just send me a suggestion and I'll try to find a contact. Cool. All right. So let's talk about classification. So I mean, as the name says, classification algorithm is supposed to classify the output. So it can be either true or false. It could be either white or black. It could be male or female. Any kind of classification you want to do and you want to predict, that would be a classification algorithm. Why do we call it? Another reason why we call it the classification algorithm is because it assigns it looks at the data and then it assigns a specific class to it. And I mean, classification can always be like, if you talk about binary values, like there are 2 classes in it. You either have 0 or 1, 2 classes. If you have male or female, you have two classes available in this classification, male or female. So in the back end, that's how it works. It looks at data and classifies them into 2 things. It can be more than 2 things. A very simple, use case would be spam emails. You want to classify, you want to predict if the email is spam or not. That would be a classification algorithm. If you're working for L Shop or you're working for Power and you want to predict whether the customer is going to buy a specific product or not, the output, now the use case is complicated, right? You want to see if the user is going to buy this product or not, but the output will always be if it's buying or not buying. So the use case can be super complicated. You can get the data from different sources, but the end result, the output should be yes or no. And that's the classification algorithm you have to use. If you want to make, like, if you want to classify fruits, right, based on different factors, their shape, their size, their color, and you want to define them in different classifications, that would be also a classification algorithm. Another example would be gender classification. This we already discussed, and stock market price. Now, stock market is a very complicated area. Stock market, you don't only, of course, you want to predict the price, but there are many things you want to predict in the price. Sometimes you want to predict the price at a specific time. You want to predict the price, either it's going to go high or low. It depends a lot on your trading strategy. You're going long on it. You're going short on the stock. So depending on which business case you're looking at when it comes to stock market prediction, the kind of algorithm you use also changes. It could either be regression, it could be classification. But if you only want to predict if, for example, it's going to go high or low, that's it. That would be a classification algorithm. There is when you classify things, right? When you say like this is an apple, this is an orange. This is also very similar to clustering algorithms, because in clustering algorithms you do the same thing. You look at the data and you cluster them together based on the patterns they have. But they're similar, but they're not the same. There's a difference between classification and clustering, and the difference is that clustering you apply to get insights into your data. Clustering you will apply based on how the data already exists. But in classification, you look at the data and you try to predict what will happen in the future. So clustering is done now, classification is done in the future. And classification also uses information based on historical patterns. Clustering also uses that, but I mean, clustering, the only difference I would say is now and the future part. That would be a huge differentiation between clustering and classification. We will cover clustering more. But okay. So that was classification, but let's look at the different algorithms inside classification. The most commonly used one is logistic regression. Now there are 2 kinds of algorithms called logistic regression. One, logistic regression, as the name says, is for regression-based algorithm. And there's another one, logistic regression, which is only for classification-based algorithm. It can be used for both, actually. And that's why it's a very popular one. Yeah. This method is most commonly used when you want to predict a binary value. And the reason for that is that when you look at the algorithm and you try to when the prediction happens, the way the algorithm works is it tries to map the data based on the scale of 0 to 1 on both axes, x and y. So it tries to classify them based on So for example, if you're trying to classify male and female, right? It will look at the previous historical data, and then you specify like kind of a boundary line. You specify like this is the threshold I apply on the data by saying like if the value is below 50%, classify this as male. If it's higher than 50%, classify this as female. And based on that threshold is this line, the green line you see over there. It then tries to predict what kind of data is male and female. And when the plotting is done, or when the training is done, and then you want to take a look at what kind of data was predicted, it will always be plotted between the scales of 0 and 1. Another way to explain is that the mathematical function which supports this algorithm only supports a scale from 0 to 1. And that's why when you train something on this algorithm, you cannot train it using male and female. You have to transform the text to a binary value and then train this algorithm. The most important thing about this function is this line, the green line. That line is called actually the sigmoid value. There's a function called the sigmoid function. What it does is that that's the threshold value I was talking about. Like you specify a threshold value. It can be any value. It could either be 0.2, 0.5, or 0.8. But if you specify a value 0.8, which is too high, you are kind of telling the algorithm like, in case everything above 0.8 depends on your classification, right? Now, if you're looking at spam emails, if you start from a very simple one, 0.5, there's a 50-50 chance the email can be spam or not. But if you increase, and that's how you tune the algorithm. If you increase the threshold value and increase it to 0.6, now there's a 60% chance it can be spam, 40% it can be not. Then you increase it more. So based on the sigmoid function, the more you tune the algorithm, the output will also change. So yeah, I mean, algorithm learns on its historical data, but this is a human way of actually tuning the algorithm, telling it like, hey, I think your output is wrong. And if we tune it to 0.5 to 0.51, that's a very small tuning, right? But you could also tune it all the way up to 0.9. That will give you values according to your own control environment. Yeah, I mean, the use cases are very similar. So it's used to predict if it's going to rain or not. Spam detection, diabetes prediction, cancer detection. Of course, cancer and diabetes are more complex use cases, but it's used over there a lot as well. Did you understand this logistic regression? It is a bit theory work around it. That was a challenge for me, like how to explain these algorithms without actually showing you the coding for it. So the plan is to show you how to code them, but it's important to understand the concept first. But please ask questions if there's some confusion around it. Logistic regression itself has 3 types. So you have a binary logistic regression, which is the one we were discussing until now. For example, it could be 0, 1, pass or fail. You can have a multi-class logistic regression. So instead of using 2 classes, you're using 3 classes, 4 classes, 5 classes. Or there's also an ordinal, like you can specify the strength. It's a low, medium, or high. Most of the time we use the first 2, the binary one and the multi-class one. So let's take an example for how a binary logistic regression would work. So let's say we have given you a data set, which is for you, right? It's you are logging your hours, and you want to predict if you will pass or fail the exam. Now, for you to be able to predict, for you to be able to do that properly, the data set which we have used is how many, is it hours? Number of hours slept and the number of hours spent focusing on or studying. And we are assuming that based on these 2 features, we'll be able to predict if the person, if you will pass or fail the exam. So what you have done is you have taken all the historical information, you collected how many hours you slept, how many hours you studied for a specific exam, and then what was the outcome for that paper. You had like four values, and that's fine. So what you did was you then used logistic regression to predict how that would be done. So this prediction is then displayed. I mean, first you have to visualize it, right? You have to see how this was done. Right now, the data is between 3.23 to 9.21. So 3.23 is the second row, which has the lowest amount of data. Then you have the highest amount of hours, which is 9.21. So when you visualize it, that's the data analysis part, right? When you have to visualize your data in the form of a graph and see how the values are. So when you visualize the data, that data will be visualized on the graph from -2 to 12, for example. That's all data sets you have. In this diagram, we have used more than four entries, just to give you an idea. So this is not using logistic regression right now, because logistic regression only works from 0 to 1. But this is data in this row format. You have not transformed it. So so what you have done now is you have been given a data set, you have visualized it. The second thing you would do is you would transform those values. The values you had earlier, which was 9.12, 8.64, number of hours you slept or studied, into a sigmoid activation function. No, sorry, you would pass them to a sigmoid activation function, and that when you use that function, it gives you a value between 0 and 1. And that's the value which you need to use in your logistic regression. That's a transformation I was talking about. Like if you have a text-based information like male or female, that has to be transformed to 0 to 1. If you have a data which was flawed, like 9 point something or whatever, that has to be transformed into a 0 to 1 value. So you do that, and then you have to specify a threshold value, and that's entirely up to you. The standard is that we start from a 50-50 basis of threshold value. You start with that, right? You start with the standard 50-50, and then you increase or decrease it to see how the performance of the model is doing. So you specify that. Yeah, and then you start making predictions. Now, this is a theoretical explanation of how the predictions will be made. This is an explanation of the mathematical function it uses. And yeah, you just need to see the output for that function. So practically when you're programming it, what you do is, this is okay, let me show you. So until here, everything was programming part. What you did was you first took the data, you transformed it from, you first took the data, you visualize it on a graph, you then transformed it using a sigmoid function that you have to do. You then design the threshold value, which would be the value of P. That is also a coding part. But here, this is something which is not coding, it's more of a theory part. So this is kind of defining the steps, what you need to do for you able to get the right prediction. So when you are done with this one, in Python, what you do is you call one line, and that will take care of all of these steps. That line is responsible for training and generating the output of that algorithm. And yeah. So if you specify, depending on what kind of threshold function you specified earlier, if, for example, this model returns 0.4, in logistic regression, the output is always 0 point something. So that output is then automatically multiplied by 100, and that would give you like a percentage. So if the output is 0.4 for this specific model, then that means that there's a 40% chance that the person would pass. But here is where the decision boundary comes in. Now, if the decision boundary here, because when you started from here and you said like the decision boundary was 0.5, and the output from here was 0.4, then that means that the person didn't pass, the person failed. But if the decision boundary here was 0.5 and the output here was 0.5 or higher, and that meant the person passed. So that's how the prediction is done. If you see a lot of outputs are coming as passed, a lot of outputs are just passed, and you know that this didn't happen, because one way to test the algorithm, obviously people want to predict in the future, right? But one way to test the algorithm is if you test it on historical data. And when you that's a way to test and see like if the output was right or wrong. When you test that and you see most of the answers are wrong, it should have been fail, whereas becoming in pass. So you change the threshold value. You then either increase it or decrease it to see how the model is behaving. Again, it makes more sense if you program it. But I hope this covered like the basics of how logistic regression works. Any questions? Or I do have a question on the chat, so let's take that. Yeah. So the question is 0.8, for example. Yeah, 0.8 in this scenario would mean that there's an 80% chance that it would either fail or pass, or if the email is spam or not. Yeah, we kind of covered the cost function. Okay. There's the cost function we need to take a look at, and that is called gradient descent. Now, as we discussed earlier, the role for the cost function, or the responsibility of the cost function, is to increase or decrease the performance of the model. And by performance, we mean that how can we get the right value of the model. So if you think the model is totally off, is giving the wrong predictions, there are many ways to fix it. You start looking at, of course, you can start looking at everything from step one. Data might be wrong. Data has not been clean enough. But that is a longer step. So the first thing you do when you want to increase the performance of the model is to look at the cost function. And the cost function was, again, the boundary line we spoke about, right? You can either change the value of the cost function, or you could change the cost function completely. And the cost function also have various functions around it. And one of the types is this gradient descent. So this is another algorithm which is used to minimize the error rate inside a cost function. So what the gradient descent tries to do is it looks at the mistakes and it tries to minimize those mistakes. So of course you have a manual process where you specify the value. So the manual process was you could specify it from 0.5 to 0.4, 0.9. But if you use a gradient descent cost function, it will automatically try to reduce the errors. Yeah. So an easy way to tell that would be that you could start from that point. Like in the graph, it starts all the way from the starting point, and it does various iterations on the prediction of the algorithm. It tries once, twice, 3 times, 4 times, and it will do it until it thinks that the error rate has been minimized. And you will reach a final value, which is over here. And that's the convergence, right? That is called convergence. Why is it called convergence? It's because that's the point where you can get the optimal value, but it will keep on going up, right? It will keep on performing the iterations until you stop it. But convergence is where would be the optimal one for you, optimal value for you. Yeah, Ulrich, you had a question? You could say that. That's a very good point, actually. You could say that, yeah. That there are many ways to do this, but this is one of the ways you can do that. Yeah. So if we want to visualize it, that's how a gradient descent algorithm will work. So what this algorithm is trying to do is to minimize the number of errors, and it starts by various iterations. It starts with the first iteration, and it goes all the way down until it finds the right sweet spot, which would be like, this is the right prediction we need. Should we take a break now and then meet in 15 minutes, like 3:30 then? Yeah. All right. Okay. So the last step you do is that when you run the algorithm and you get like the prediction scores, you get them in terms of like a probability scores, they're not gonna be in a classification form. So the probability scores you will get would probably be between 0.96, like that's the percentage thing we spoke about earlier, right? So you can either take them as is, so the output you will get will be like 0.96, 0.448, 0.015. What these values actually show is that if you multiply them by 100, the value would be, the first one is 96%, second one is 44%. Then you have 1.5%, 78%, 97%, and so forth. You could also classify this as 0 or 1. That's entirely up to you. That depends on how you want the output to be. If you want the output to be in terms of percentage, you can do it. You can stop on the probabilities part. Or if you want the output to be actually a classifier, saying like this is a male or a female, or this is black or white, or it's spam or not, then you can classify it using a classification function. It's just different steps. One line will do this, the second line will do that. And most of the machine learning has the same kind of steps all in the whole application. If you look at one machine learning algorithm, if you take away the data processing part, if you take away the data cleansing part, if you take away the feature engineering part, the whole machine learning algorithm is just like 10 lines of code, and that's it. And it's the same lines of code. You define the cost function, you minimize it, you define the decision boundary, you then train the model, you load up the data, train the model, you see the output in terms of probabilities or classification, and then you improve it. But improving part is again rerunning with different kind of cost functions or decision boundaries. Yeah. So yeah, then the last step would be to train the model, evaluate it. If you think the error rate is too high, focus on the cost, focus on try with the cost first, try with the tuning of the model first. That's always the best approach to do. If that doesn't help, then go back to the data which you had and work on cleaning the data further. Second step would be improving the features. And if they don't help, then you're probably not using the right algorithm. You have to rethink if this is the right classification algorithms will work for you or not. Sometimes it can also happen that you started off with the classification algorithm, you tried 5 or 6 algorithms, and it might be that you were probably looking at the wrong kind of classification. You probably needed a regression algorithm, and you have to jump on that one. That's the easy part, because all you have to do is like you spend like 10 lines in the machine learning programming. So you just change that with something else. Most of the code will remain the same. It's just the type of algorithm you're using. For linear regression and similar functions in classification algorithm, the structure is the same. You have a cost, you have a decision boundary, and then you have to work around it. Regression, the kind of structure changes, not so much, but there's one more line which has to be added. A clustering is entirely a different kind of format. Okay. The second last step is very important. So what you have to do is that you have to measure the accuracy of the output. How is that done? That is done based on historical data. So as I said, like when you try to predict for the future, most of the time the mistake we do is we try to predict for tomorrow or day after tomorrow. But you could also predict for, you could also do a prediction in the past. And that's how the prediction rate is generated. You that's how the testing of the prediction is done. So you divide the data set into different. So practically, when we try to test the algorithm, we divide the data set into three parts. One of them is a train part, the other one is the test part, and the third is a production part. And then, sorry, the training part. And once we train the algorithm with the training data, we then test it with the one which we have not exposed it to yet. This area is covered a lot in Andrew Ng's book, Yearning Machine Learning, where they actually talk about the practical use cases and how would you actually develop a machine learning algorithm. Okay. Any questions on linear regression? All right. We're now going to jump over to naive. Yeah, sorry. That's a good question. I don't know. I'm just following the standard. That's a very good point, actually. Error function. You know what? I'll try to search for that answer, and I'll come back to you on this one. I'm assuming there are a few other algorithms which also have like an error function built onto those. But that's just an assumption. I might be wrong. But I've never come across that question before. What's your name? I'm sorry? Thomas. I'll follow up, Thomas, on this one. I'll try to see what the answer is. Okay, so in classification, any other questions? All right. So in the second algorithm we will study today, and that's we don't have the time to study it completely today. So I'll just give an introduction to this one and then we'll stop. That's a naive Bayes algorithm. So the naive Bayes algorithm is also a very popular algorithm, commonly used. This function, this algorithm works a lot on, now, the previous algorithm we worked with, it was based on classification, right? We spoke about 2 kinds of classification, 3 kinds of classifications. This algorithm kind of does the same thing, but it does not, it's based on the feature sets. Now, if you have features in your algorithm which are unrelated to other features, then this is the algorithm you should use. Now, this is a very this is a very technical thing, and you should only think about it when you're not getting the right kind of prediction score from your algorithm. One reason is that the feature sets which you have created in your algorithm, they are unrelated. They are not dependent on each other. Let's look at Ruta's data set, right? You probably were creating some time-related features on that one. And for example, you created another feature which was entirely about personal information. And these are 2 feature sets which are not related, belong to the same data sets, but you think they are important enough for the prediction in that algorithm. So then in that case, you should not use a linear regression algorithm. You should use a naive Bayes algorithm. Yeah. Another thing about naive Bayes is that this formula is very interesting. When we spoke about historical events, and we talk about how the algorithm actually defines or understands how this has happened in the past, this formula is used a lot in that area. This kind of shows that the probability of something which happened before will also happen again. So the Bayes naive Bayes classification algorithm is based on a Bayes theorem, which states that which looks at the possibilities of something which has happened before and how can it happen in the future. Bayes algorithm is a bit more complicated and I need more time to actually teach it. I thought today linear regression, logistic regression would take most of our time, but it has not. So I don't have anything else to teach for now. So I'm just wondering if you have any questions. Do you think it's okay if we finish up early? Yeah. Okay. This class and the upcoming class, these two classes are very hard classes in my opinion, because in these two classes we talk about we kind of deep dive into algorithms, how they work. We deep dive into their cost functions. We deep dive into why one algorithm should be used based on the other one. These two are a bit hard classes. So stay with me, work with me on these two classes. The remaining was the third one on the machine learning is the last one on the machine learning is a very easy one, because then we go back to different algorithms and discuss the use cases. Yeah. So if you feel like you leave from the class, the lecture, and you feel like you didn't get anything, it's okay to feel like that. But send me a message and I'll try to elaborate it further, or I'll try to fix it in the next class, because it's important for me that you understand these concepts. Because once you start programming, you need to know these concepts when you start programming. It helps. Programming machine learning with the algorithm part isn't hard. It's a very easy thing to do. Data processing is the hardest part. You have already covered that. So I think this would be an easy sailing for you. But concept-wise, it's hard. So yeah, keep an open channel. Let me know if there's anything confusing and we'll try to fix it. All right. Well, thank you so much. Again, the lab right now will happen, but we'll try to help you with the assignment. So if you have any issues, just ask in the lab. So for Zoom, I will stop recording and I will also